This is question number 5 taken from exercise 8.2 NCERT. It says that ABCD is a parallelogram where E and F are the midpoints of sides AB and CD. And you can see that ABCD, this figure is given a parallelogram where we have been given that E being the midpoint of AB and F is the midpoint of DC. So this is the information that is the given part. Now, what we have to prove here that show that the line segment AF and EC trisect. Trisect means dividing into 3 equal parts. So it is trisecting the diagonal BD. That means this line AF and EC is dividing this BD into 3 equal parts. So in short, we have to prove DP is equal to PQ and PQ is equal to BQ. That's what we have to prove in this question. I've already written the given and true proof. We have to prove these 3 lengths are equal. So first we will start with the proof part. This question will have 3 parts in which in the first section or the first part we will be proving this figure as a parallelogram by proving one pair of opposite sides as equal and then writing these lines as parallel. In the next section we will be taking this triangle and we'll be applying converse of BPT to prove that DP is equal to PQ. And the third and the final part, we'll be considering this triangle and applying the converse of midpoint. We'll be proving that this PQ is equal to BQ. So first we are going to prove this as a parallelogram. So what we'll do, we'll write AB is equal to DC, and this reason is opposite sides of parallelogram. As you know, we can replace AB with twice AE as E is the midpoint. So we'll write this as twice AE. And similarly, we'll be writing DC as twice CF. So now if you cancel this 2 and 2, we get AE is equal to FC. Further, we know that they are also parallel, right? Because AB is parallel to DC, so parts of parallel line are parallel. So we got AE is parallel to FC. Now, once it becomes a parallelogram, we can write there. First, we'll write this as a parallelogram, and then we can write the other pair as parallel, that is AF parallel to CE. So this way, we prove this figure. We prove this figure a parallelogram, and we have also proved that this line is parallel to this. Now we'll be considering a triangle, say this one, and we'll be applying the converse of midpoint here. So we are considering triangle here. We'll consider triangle DQC. As you know here, F is the midpoint of DC, as we know. And we also know that FP is parallel to CQ. That is from equation 1. As we have already proved, A is parallel to AF parallel to EC. And this is now, therefore, by converse of midpoint theorem, we can say P is the midpoint of DQ. That is, we can write here DP is equal to PQ. Now, it implies that AF and EC are bisected as BD. So this is the first part, second part of this working. Now, similarly, we will consider the other triangle. This is triangle APB. So in this triangle also, we'll do in the same manner. What we'll write here is the midpoint of AB that is given, right? And then EQ is parallel to AP, as we have already proved, AF parallel to EC. So by converse of, again, midpoint theorem, we can say that here also Q is the midpoint of PB. And once we prove this, we can say that PQ is equal to BQ. So from these two equations, that means from this equation, we got DP is equal to PQ, right? And from this equation, we got PQ is equal to BQ. Therefore, we can finally write that from 1 and 2, from equation 1, it's not this P1, this is equation 1 and equation 2, that is, this is equation 1 and this is equation 2. From here, we can write that DP is equal to PQ is equal to BQ. And that is what we are asked to prove.